Okay, BioChem Basics Take 2. Let's see if we can do a better job tonight. So, again, BioChem means that everything is carbon-based. I promise you, I am going to get this writing down. Besides carbon, we're also going to have hydrogen, oxygen, sulfur, phosphorus, and nitrogen involved in these molecules. We're going to be talking about a varied ratio. They are not going to be set. Like we saw with ionic compounds. It's not going to be the case here. And probably the most important part that is going to help us get through this are, of course, knowing the functional groups. Okay, that's the basics of the basics. Let's start fresh and talk about the shapes of molecules. Organic compounds can have a varied molecular shape. We could have straight chains, straight chains are basically a string of carbons. Something like that. A couple things to note. We tend to leave the hydrogens off of the molecule. Basically, this is because they just kind of get in the way. If I was to write this with the hydrogens in it, it would be CH3, CH2, 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 CH3. You can see that's kind of obnoxious. If we were literally to put them on the molecule, I mean, look what it does to, oops, to your drawing. Hang on, let's undo those. Oh, well, that didn't make it any better, but that would be all of the bonds. That would be our H's. And as you can tell, it just gets kind of obnoxious. So therefore, we tend to leave the H's off of the molecule. You have to remember that they are there, though. So, other than a straight chain, we can have a branched chain. Basically, a branched chain would be a string of carbons with a branch off of it. The trick is finding the longest carbon chain to know what's the difference between the branch and what's the difference between the main chain. So, for example, if we were to look at this chain of carbons, you'd see there's 1, 2, 3, 4, 5, 6, 7 carbons in that chain. However, I'll choose a different color here, and we consider that chain of carbons, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in that chain. That makes this your straight chain, and these carbons down here are your branch. Okay, so we have either straight chains or we have branched chains. So let's take a look at our last shape. Our last shape to consider are called cyclics. Cyclics are rings. Rings of carbon. You can have entirely carbons in the ring, or sometimes we like to throw some other molecules into the ring. We could throw nitrogens into the ring. That's a possibility. This time we threw an oxygen into the ring. So these would both be cyclics. Okay. Just one last little note before we move on. If I have a ring structure and I have alternating double bonds like you see there, this particular ring is called a phenyl. We also refer to them as aromatics. We see them in lots of different places. We won't personally deal with them on a regular basis, but by their name, I'm hoping you put together that they have odors, they're aromas. And one of the most common ones, as a matter of fact, the one I drew there, assuming that I put all H's around here like I should, this would be benzene. And benzene is often used in refrigerants. So you have benzene as part of the chemicals that make your refrigerator work as your refrigerator. Okay, so that's about it for the take 2 of the basic BioChem section. The other segments that I did previously are pretty good and we can survive, but this one was pretty awful, so I thought I'd do it again and repost it. All right, move on to the next segment, please.